A volcano in the Caribbean with a history of violent eruptions that have killed thousands of people is heating up. Here is what you need to know. Residents of Saint Vincent and the Grenadines.
The Caribbean is not just about sunshine and calm beaches. Beneath its beauty, the ground has started to hum again. From Saint Vincent to Montserrat, people are talking about strange tremors, deep rumbles, and glowing skies that no one expected to see again. Could the islands be waking up? Or is the Earth simply reminding us who is really in charge? Either way, scientists are watching closely, and so are the locals who have lived through eruptions before. But what exactly are scientists seeing beneath these islands that has them so alert? And could this be the start of something bigger? What is happening right now? Right now, monitoring centers record unrest at several Caribbean volcanoes. Kikum is a submarine volcano north of Grenada. On August 27th and August 28th, 2025, seismometers registered an increase in tremors near Kikum. About 800 small earthquakes were counted during that short period. Earlier unrest at Kikum included a much larger episode in February 2024 when agencies logged about 3,400 events. Those events raised alert levels and prompted regional notices. La Soufrière on Saint Vincent erupted explosively from December 27, 2020 to April 2021. That eruption involved ash explosions and dome activity. Since then, the University of the West Indies, Seismic Research Centre and local agencies have kept continuous monitoring of La Soufrière. Soufrière Hills on Montserrat remains under watch by the Montserrat Volcano Observatory. Reports in 2024 and 2025 describe low to moderate activity and steady seismic monitoring. Mount Pelée on Martinique has shown low-level unrest since around 2019. Seismic events and gas observations have kept scientists alert. Regional observatories and national emergency offices have issued bulletins and weekly reports for these sites. The short list of currently active or restless locations is Kikum, La Soufrière, Soufrière Hills, and Mount Pelée. Each site shows different signals. Some show many small earthquakes, others show gas release or ground change. All are watched closely by monitoring groups. Local reporting and regional summaries show how people noticed ground shaking and unusual sea sounds near Grenada. Fishermen in Grenada reported small swellings and unusual mud on the surface in past unrest episodes. Authorities in islands near La Soufrière ordered evacuations in 2021 when ash and pyroclastic flows threatened towns. Those evacuations involved national emergency management offices coordinating transport and shelters. After the 2020 to 2021 eruption, researchers studied lava dome changes and paid close attention to gas measurements. In August 2025, the quick swarm near Kikum did not lead to an immediate eruption at the surface. Subsea vents can change chemistry and release bubbles without visible lava on the sea surface. Fishermen around that area and port authorities watch these signs because they affect shipping and fishing safety. The pattern of many small earthquakes in short time spans is a key signal used by scientists. Scientists also track longer-term trends, such as increasing earthquake rates over weeks or months. For residents, the main point is that monitoring is active and agencies publish updates when thresholds are crossed. When bulletins come out, leaders of this area and emergency managers use them to plan steps like moving people away from ashfall zones or preparing shelters. The data from these events form a record that informs future responses and helps scientists learn how each volcano behaves. Authorities also study secondary effects, such as how ash can clog water filters and harm crops. Researchers work with farmers to test the soil and advise on safe cleanup methods. These steps help communities recover faster after intense events. In Grenada, maritime notices inform ships to avoid affected zones when submarine unrest is active. Ports and fishing operations follow guidance from national authorities. Monitoring teams also note effects on aviation when ash plumes reach flight levels. Ash can reduce visibility and damage aircraft engines. so airlines and aviation authorities monitor ash advisories closely. Observatories publish technical bulletins that list observed earthquakes, gas readings, and notes on ground change. Those bulletins use understandable terminology for emergency managers and a more detailed technical section for researchers. Scientists archive data for later study so that future predictions can be improved. The public benefits from this careful record-keeping because it reduces uncertainty in later events. Researchers also run lab studies on rock samples and gases to understand magma composition and how it behaves when it reaches the surface. But with all this monitoring and careful analysis, one question remains: who's actually keeping watch when the Earth starts to stir? Who is watching? People and agencies. Several organizations track the islands and publish public updates. The University of the West Indies Seismic Research Center leads regional monitoring for English-speaking islands. The Montserrat Volcano Observatory issues weekly reports for Soufrière Hills and maintains local instruments. The Observatoire volcanologique et sismologique de Martinique monitors Mount Pelée in Martinique. The Smithsonian Global Volcanism Program compiles weekly reports on worldwide activity, including Caribbean updates. National emergency agencies publish notices. Examples include the National Emergency Management Organization in Saint Vincent and the National Disaster Management Agency in Grenada. Key scientists named in public records include Professor Richard Robertson from the University of the West Indies Seismic Research Center and Dr. Graham Ryan from Montserrat Volcano Observatory when he is quoted in official briefings. These teams use seismometers, gas sensors, GPS, and satellite techniques. Seismometers record earthquake counts and magnitudes. Gas sensors measure sulfur dioxide and other gases. GPS stations and satellite radar measure ground movement over time. Field researchers inspect volcanic domes and vents when it is safe. Together, these instruments create a picture that guides local warnings. When seismology, gas, and deformation change together, agencies consider raising alerts. When one type of signal changes alone, experts study the context and past behavior of each volcano. Regular briefings and weekly bulletins help emergency managers plan and inform residents. The University of the West Indies Seismic Research Center maintains a network of seismometers across islands, including instruments in Trinidad, Barbados, and Grenada. These instruments send data in near real time to a central server where experts analyze patterns. Montserrat Volcano Observatory on Montserrat focuses on a single island with dense monitoring around Soufrière Hills. Its staff perform field checks and issue weekly reports describing dome status and seismic trends. The Observatoire in Martinique operates gas measurement stations near Mount Pelée and uses drones for sampling when conditions permit. The Smithsonian Global Volcanism Program does not run local stations, but compiles reports and historical data that researchers use. National emergency offices, such as the National Emergency Management Organization, coordinate evacuations and public messaging, and liaise with observatory scientists. Professor Richard Robertson has led public briefings and explained how seismic swarms are interpreted. Dr. Graham Ryan has overseen monitoring and community outreach in Montserrat when MVO issues statements. Scientists work with social officials to translate technical alerts into clear actions for residents. Instruments alone do not protect people. They use radio, phone, and social media to spread warnings. Training exercises and drills occur in some islands to prepare for ashfall or lava flow threats. Funding and staffing can limit how many instruments an observatory can operate. Researchers call for more support because long-term data improves forecasts and saves lives. Seismometers pick up tiny quakes that people cannot feel. Specialists examine the pattern of those quakes to tell whether magma is moving or whether the shaking is tectonic. Gas sensors measure how much sulfur dioxide escapes the volcano. A sharp rise in sulfur dioxide often shows that fresh magma is near the surface. Satellite instruments measure heat and small ground shifts over wide areas. Instruments on the ground and in the sky work together to provide a fuller picture. The work of groups such as the University of the West Indies Seismic Research Centre and Montserrat Volcano Observatory depends on trained local staff and field geologists. Laboratory analysts perform chemical tests on gas and ash samples. Academic institutions help by studying past eruptions to spot patterns. International partners sometimes send extra equipment after larger unrest, so more data can be collected. Training programs teach technicians how to maintain instruments and interpret data. Stronger networks help provide faster warnings to the public. Public communication is a major part of observatory work. Scientists prepare maps of likely ashfall and check which towns and roads might be affected. They share those maps with civil defense and community leaders to plan actions. The Smithsonian Global Volcanism Program collects reports and keeps a public archive that helps scientists find historical records and compare current unrest with past patterns. National agencies such as the National Emergency Management Organization in Saint Vincent and the National Disaster Management Agency in Grenada coordinate with observatories to deliver timely notices. Data sharing agreements help islands pool information and improve regional response. Scientists like Professor Richard Robertson explain technical results in public briefings so that officials can act on the best available evidence. But what happens when these readings suddenly spike beyond expectation, when the Earth's signals hint at something far more dangerous? The volcanoes. Kickham. Jenny sits below sea level about 8 kilometers north of Grenada. Its submarine vent is close to shipping lanes, and therefore it is important for maritime safety. Kickham. Jenny moves in short, intense bursts of seismicity. On August 27th and 28th, 2025, unrest included roughly 800 events in a short time window. The February 2024 episode produced about 3,400 events. Those numbers come from regional monitoring reports and weekly summaries. La Soufrière on Saint Vincent is a large and active volcano. The December 27th, 2020 to April 2021 eruption was explosive and destructive in populated areas around the volcano. That event is an important context for current monitoring because the volcano can produce ash, pyroclastic flows, and dome changes. Soufrière hills on Montserrat produced long-term dome cycles from the mid-1990s. The Montserrat Volcano Observatory keeps close watch on the dome and seismic rates. Mount Pelée on Martinique is known for its deadly 1902 eruption. Modern monitoring shows low-level unrest and occasional seismic swarms since 2019. Each named volcano has a record and a monitoring history. Scientists use that record to compare current changes with past behavior. Data such as daily earthquake counts and reported gas fluxes form the factual base for short-term forecasts. Kickham. Jenny lies roughly at latitude 12 degrees north and longitude 61 degrees west, just north of Grenada. Its submarine vent is close to shipping lanes, and therefore it is important for maritime safety. La Soufrière rises above the central area of Saint Vincent and sits near several towns that felt ash and shaking in 2021. Soufrière Hills occupies the center of Montserrat and has a long record of dome collapse and pyroclastic flow events since the mid-1990s. Mount Pelée dominates northern Martinique and rests near populated zones that remember the 1902 event. The recent monitoring reports list daily earthquake counts, dates of elevated gas readings, and notes about ground tilt when detected. Seismometers record small magnitudes that often indicate magma movement at shallow depths. Gas instruments measure sulfur dioxide and other gases to estimate the degassing rate. GPS and satellite radar show millimeter to centimeter scale changes in ground level that hint at magma filling a shallow reservoir. For each volcano, the mix of these data types differs. Kickham. Jenny produces strong seismic signals, but less visible gas at the sea surface. La Soufrière may show gas pulses and dome shifts. Soufrière Hills shows slow dome growth episodes that are visible to field teams. Mount Pelée shows small seismic bursts that can come without an immediate surface change. This detail matters because each volcano requires a tailored approach to risk communication and response. Kickham, Jenny has no permanent island above its vent, so any eruptive activity stays hidden below the sea surface unless it is large. Scientists study bathymetry maps to see how the seafloor changes after unrest. La Soufrière sits near populated communities such as Fancy and Barreau-Allier that felt ash and fallout during the 2021 eruption. On Montserrat, the town of Plymouth was lost to earlier eruptions. That history affects how people remember volcanic risk and how they respond to warnings today. Mount Pelée sits close to the town of Saint-Pierre, which has a long memory of the 1902 event. Modern building codes and emergency plans reflect those histories. Researchers also track landslide risk on volcano flanks because heavy rain after eruptions can lead to dangerous mudflows. River valleys below La Soufrière and Soufrière Hills are monitored during heavy rains. Volcano hazards include ashfall, lava domes, pyroclastic flows, and lahars, depending on the volcano and weather. Each hazard requires a different response from residents and emergency teams. That is why observatories provide scenario-based guidance and why communities train for different outcomes. Scientists use thermal cameras on satellites to detect new heat near vents. Bathymetric surveys help map seafloor changes after submarine unrest. These tools reveal details that are not visible from shore. Satellite radar tracks ground movement over months and years. Gas testing shows whether fresh magma contains more volatile elements. Researchers collect ash and gas samples to analyze composition. These measurements help scientists estimate how violent a future eruptive phase might be and what hazards it could produce. Authorities then plan evacuations and other measures based on that assessment. But what if the instruments began showing signals that didn't fit any known pattern? Something no one could explain yet. Why scientists did not expect this? Scientists say some recent signals surprised them because the pattern was not the one expected for each volcano. Submarine systems like Kickham, Jenny can show rapid swarms that are hard to forecast. A sudden jump in events may reflect a new pulse of magma or a hydrothermal change underwater. Multiple islands showing unrest at similar times can raise a question about regional tectonic stress. Tectonic plates and local faults change stress across the area. If magma is already pressurized, a small stress change can trigger events. Experts call the idea that a fault or earthquake can trigger a volcano a tested scientific hypothesis. That idea relies on measurements of stress, timing, and regional history. Other reasons for surprise include unexpected gas signals or deformation that appears without large earthquakes. Some volcanoes respond in subtle ways that only careful monitoring can detect. Scientists now look for links between seismic swarms, gas release, and ground movement. They use combined data from seismometers, gas instruments, GPS, and satellite radar. When these signals align, the case for renewed activity is stronger. When they conflict, experts take time to study and avoid hasty choices. Monitoring teams keep notes, collect data, and issue measured guidance to civil authorities. When scientists call a pattern surprising, they mean the signals differ from prior expectations based on past records. For example, a volcano that usually gives clear long-term deformation before an eruption, but now shows only a short seismic burst, will raise new questions. In the case of Kickham Jenny, the speed of the swarm in August 2025 was notable because it came with no large regional earthquake to explain the trigger. Scientists consider whether small stress changes, pressure pulses in magma, or hydrothermal shifts could cause the activity. They compare the timing with regional fault activity and known tectonic plate motions. If several volcanoes show unrest near the same time, experts test whether the events are linked by a common cause or whether they are independent. This testing uses statistical analysis of event timing and study of the physical structure below each volcano. Field samples and gas chemistry add clues about fresh magma or recycled rock moving in the system. Researchers stress caution in public messaging because models carry uncertainty. When models change after new data arrives, agencies update their guidance. The public benefits when scientists explain what is known, what is likely, and what remains uncertain. That is why agencies publish technical bulletins and why emergency offices translate those bulletins into simple steps for people. To test ideas about triggers, scientists use past records of earthquakes and volcanic unrest. They also use physical models that simulate how magma moves inside the Earth. If a model shows that a small stress change could increase eruption chances when magma is close to the surface, then scientists plan field studies to check gases and deformation. Researchers publish findings in peer-reviewed journals and share data with regional partners so that everyone can evaluate the evidence. The process is careful and methodical because an incorrect public warning can cause needless disruption. At the same time, delayed action when danger is real can cost lives. So observatories and emergency offices balance caution with preparedness. Scientists also study how to improve early warning systems using better sensors and faster data links. Improving models requires long data series and repeated field studies. Scientists also plan more bathymetry surveys near Kikum-Jenny to check for seafloor changes after swarms. These studies help identify whether the activity is a short-term pulse or the start of a longer unrest phase. Modelers continue to refine simulations that test how magma pressure, fault slip, and fluid flow interact below volcanoes. Regular community drills and clear evacuation maps make responses faster and reduce harm when alerts come soon. Continued investment in monitoring saves resources and lives. Nature always finds a way to remind us who is in charge, and the Caribbean is feeling that reminder again. These volcanoes may sleep, but they never forget to wake. What matters is how ready we are when they do. So, what is your take? Just normal rumbling or something bigger on the horizon? Let us talk in the comments. And if you enjoyed this video, make sure to like and subscribe to our channel for more.